In the last video, I gave Claude real trading tools through MCP. It researched the market, it designed a strategy, it wrote the PineScript, it ran the backtest, it reviewed the result, and it made one revision. The workflow looked professional, the output looked professional, but there was one problem I could not get past. Claude was doing all of it. The same model that invented the strategy was also the model deciding whether the strategy was good. The same model that wrote the entry rules was choosing which rules to change when the backtest came back weak. That is not research. That is a student grading his own homework. If you did not watch that video, here is the whole thing in one line. Market tools go in, one language model does everything. A strategy comes out, the same model reviews itself, then it revises itself. Every important decision lives inside one long conversation, and that conversation has no rules. So today, I am taking control away from the single model and replacing it with an entire graph. 13 steps, start to finish, and you can build it along with me. Every prompt I paste is in the free guide in the Alpha Cartel Discord, link in the description. Fast version, because we have a lot to build. A normal AI workflow is a conversation. You prompt, it answers, you prompt again, and the model decides what happens next. A state graph turns that conversation into a system. 4 words and we start building. A node is a stage that does one job. An edge is the route from one stage to the next. State is the structured data every stage reads and writes, and a conditional edge is a rule that picks the next stage by reading a field in that state, not by asking a model what it feels like doing. That is the whole idea. Instead of one giant prompt, I am building a flowchart the AI has to obey. Here is the system before we write a line of it. Market regime node does research and nothing else. Strategy node turns that research into one testable hypothesis. PineScript node implements it. Compile check routes on a single field, and if the code fails, a syntax fixer repairs the error and sends it back, with a cap, so it can never loop forever. Then the backtest node writes real numbers into state, and an independent risk gatekeeper reads those numbers cold. It never saw the strategy being invented, so it has nothing to defend. Pass, reject, or insufficient evidence. Pass goes to final output. Reject goes to one bounded revision. Reject after that, and the graph stops and returns strategy rejected. 4 tools, 4 jobs. The language models reason inside nodes. MCP gives them tools. LangGraph controls flow and routing. TradingView is where the code actually runs. Let us build it. Step 1. Folder, files, packages. I am doing this the way I do everything on this channel. I am not typing the code, I am pasting a prompt into Claude Code and letting it build the project, then I read what it wrote. This first prompt creates the folder structure, installs LangGraph, the Anthropic SDK, and FastMCP, and leaves me 8 empty files that the next 12 steps fill in. Paste it, let it run, then check the tree. 4 folders, 8 files, and an import test that prints OK. If your import test fails here, fix it now, because every step after this assumes it passed. Step 2, and this is the single biggest difference from the last build. In the old workflow, the shared context was the conversation. Everything the model had ever said was available to everything the model did next. Here, the shared context is a typed object with named fields: market, timeframe, regime analysis, strategy rules, Pine code, compile status, backtest results, risk review, revision count, revision history, final status. Every node reads the fields it needs and writes the fields it owns. Nothing else. That buys me 3 things. Each node only sees relevant information, so the strategy node cannot be influenced by a compiler error it has no business seeing. Routing can be deterministic because a rule can read a number out of a field instead of asking a model for an opinion. Step 3. This is the step most people skip, and skipping it is how AI backtests turn into fiction. Before a single strategy exists, I am writing down what a strategy has to achieve to survive. Minimum trade count, maximum drawdown, minimum profit factor, minimum average trade after costs. Exposure limit, how much degradation I will accept from in sample to holdout, and a cap on return concentration, so nothing passes on the back of 2 lucky trades. I am not going to hand you universal numbers because there are none. The right thresholds depend on your market, your time frame, your strategy type, and how long the test ran. What is universal is the order of operations. You pick the numbers first, you put them in the config file, and you do not touch them because something you liked failed one of them. No moving the goalposts. Prompt 3 writes the config file, including the revision cap. I am running max revisions equals 1. Step 4. The tool layer. MCP is just a standard way to hand a model real capabilities instead of asking it to guess from memory. This prompt builds a small, fast MCP server, exposing exactly 2 tools, candles and indicator values on a defined lookback. That is all this graph is allowed to touch. One detail in the prompt matters more than the rest. Every tool return is stamped with source, timeframe, lookback, and timestamp before it enters state. If a number cannot be traced back to where it came from and when, it does not get to influence a decision. Plug your data source in where the prompt marks it, start the server, and confirm both tools are listed. Step 5. Node 1 of the graph, research, and nothing else. Its job is to classify the environment before anybody is allowed to have an opinion about a strategy. It pulls candles and indicators through the tool layer and returns a fixed set of fields: regime, trend direction, trend strength, momentum, volatility, structure, cross-market context, supporting evidence, confidence, and the data timestamp. Now look at what the prompt forbids. It cannot propose a strategy, it cannot write code, it never sees a backtest, so it cannot judge one, and it is banned from recommending parameter changes. That sounds small. It is not. In the old workflow, research and strategy happened in the same breath, which means the research was always quietly written to justify the idea the model already wanted to build. Split them, and the regime report has to stand on its own. Paste prompt 5. It writes the node function and the system prompt it runs on. Step 6. Node 2 takes that regime report and produces exactly one measurable strategy hypothesis. A spec, not code. Name, type, hypothesis, why it fits the regime, entry rules, exit rules, stop, target, trailing logic, filters, sizing assumption, when to stay flat, and expected failure conditions. That last field is the one everybody skips. A strategy that cannot tell you how it dies is not a strategy, it is a hope. The constraints in this prompt are aggressive on purpose. 1 hypothesis, not 3. 3 to 6 conditions. Every rule measurable, because a rule you cannot measure is a rule you cannot code and cannot falsify. And notice the input. This node receives the regime report and nothing else. No backtest results, no holdout data. It cannot optimize against numbers. It has never been shown. Step 7. Node 3 implements the spec in PineScript, strategy declaration, real commission and slippage in the settings from the start, clear inputs, explicit entries, explicit exits, comments on the important logic, no look ahead, no repainting, no future leakage. The rule in this prompt is one line. Implement, do not redesign. If a technical limitation forces a change, it has to declare the limitation, the change, and the effect on the strategy in 3 lines above the code. A silent redesign at the code layer is how you end up backtesting something nobody specified. Paste it, and the node writes the script into the Pine folder, ready for the chart. Step 8 is your first real branch, and it is where the graph starts behaving like a machine instead of a chat. Compile status is one field with 2 values, pass or error. Pass routes to the backtest, error routes to the syntax fixer. The fixer gets 3 things: the current code, the exact compiler message, and the original spec. It returns the error, the cause, the minimal fix, and the updated code. It is not allowed to optimize, add indicators, loosen an entry, or touch risk rules unless the fix technically requires it. Then it routes straight back to the compile check. And there is a cap on attempts. Hit it, and the graph exits as a technical failure. No infinite loops, and no model quietly rewriting the strategy to make an error disappear. Paste the script into the Pine editor. If it compiles, write pass into the status file. If it does not, copy the exact error text in. Do not paraphrase the error. The fixer needs the real message. Step 9 produces the evidence. The script runs on the strategy tester over a defined in-sample window. I'm not going to pretend this leg is fully automated because it is not. What matters is that the numbers entering state are real numbers off a real chart and that they land in state before anybody is allowed to have an opinion about them. Set commission and slippage in the Properties tab before you read a single metric. Then fill the results file: net profit, profit factor, max drawdown, win rate, trade count, average trade, Sharpe and Sortino if available, exposure, and how concentrated the profit is. Then the node stops. It reports, it does not decide. One more thing here, the test period was split before the first run. In sample for development, holdout touched once at the end by the final candidate only. If you tune against your holdout, you no longer have a holdout. You have a second training set with a better name. Step 10. This is the node the entire architecture exists for. The risk gatekeeper is a separate model call with a separate prompt and a separate job. It did not invent the strategy. It did not write the code. It has no ego in the outcome because it was never in the room when the idea was born. All it gets is the spec, the gates from step 3, and the real results. The prompt makes it check sample size, profit factor, drawdown, Sharpe, Sortino, win rate, average trade after costs, equity curve stability, cost sensitivity, exposure, regime dependency, return concentration, and overfitting risk. Then it returns one decision: pass, reject, or insufficient evidence. Insufficient evidence is the underrated one. It is not a rejection of the idea. It is the system refusing to pretend that 11 trades tell you anything. And notice this prompt also builds a hard gate function that runs before the model does. Trade count below minimum or drawdown above the limit gets rejected by plain Python. Step 11. If the gatekeeper rejects and I still have a revision left, we enter the revision node. This is where most AI trading workflows quietly turn into curve fitting, so it has the tightest prompt in the build. Before it changes anything, it must output 5 fields: observation, hypothesis, proposed change, expected effect, and what would falsify this hypothesis. One bounded change, and the limit was declared in step 3. If the revised version fails, the graph stops and return strategy rejected. That is a valid ending. A research system that cannot return no is just a strategy generator with extra steps. Step 12. 11 files, no system. Now we connect them. This prompt builds the graph itself. Every node registered, the straight edges from regime to strategy to code, and the 3 conditional edges that make this a control system instead of a pipeline. 1. After the compile check, pass to backtest, error to fixer, cap reach to technical failure. 2. After the hard gates, already decided goes to final, otherwise the gatekeeper runs. 3. After the gatekeeper, pass to final, reject with a revision left to the revision node, reject with no revisions left to final as strategy rejected. Step 13. Run the whole thing. The runner streams every node transition to the terminal, so you can watch the routing happen live instead of trusting me that it happened. It pauses at the 2 manual legs, the compile check and the backtest, and picks up where it left off once the files are filled. So here it goes. Regime node pulls data and files its report. Strategy node reads that report and writes a spec. Code node implements it, compile check does its job, and the script goes on to the chart. The numbers land in state, the hard gates run, and then the gatekeeper reads it all cold. I am putting the full trace on screen, every node output, every routing decision, and both sets of numbers. The verdict is on screen now. Every decision has a named node, a stored state, and a rule I can point to. That is not a money printer. It is a discipline machine. And in this business, discipline enforced by structure beats discipline you promised yourself at the start of a backtest. 13 steps. Structured state instead of one long conversation. A research node that only researches. A strategy node that only proposes. A code node that only implements. A compile branch that fixes technical errors and nothing else. A backtest node that reports without judging. An independent gatekeeper with gates written in advance. And one bounded revision before the system is allowed to say no. Every prompt from these 13 steps is in the guide in the Alpha Cartel Discord, step by step, in order, ready to paste. Link is in the description. Build it and post your graph trace and your gatekeeper decision in there. I want to see the rejections more than the passes. And the disclaimer, because it matters. This is educational content about building research systems. It is not financial advice. None of this is a recommendation to trade. And a backtest describes the past. It does not promise the future. Subscribe. See you in the next one.